Let's get you started with section 2.3 and get you started on some of these homework problems. This is still continuing with set theory. And so we're actually going to look at a little bit more difficult sets. And I think hopefully this will help you get through the homework in this section. All right, so we're actually going to look at three sets in this case, A, B, and C. You see that I have a universe that contains the numbers 7 through 13. And then A, B, and C are subsets of that universe. Now, in your homework, you're going to have several of these. And like one of the examples would say, find A union B intersect C. Okay, now you see those parentheses in there. And those parentheses right here, that applies just like the order of operations. So anytime you see those parentheses, you need to make sure you do this set first. Okay, so we want to do this union first. So we'll do A union B, and we can look at A and B. And remember, the union means you're going to contain any element that is either A or B. So when we do that, we are going to get this set 7, 8, 9, 10, 11, and 12 because those are all of the elements that are either in A or B. All right, now let's take this set that we just found and we're going to do an intersection of this set with C. And remember, the intersection has to contain all of the elements that are common to both. And so it's just only going to contain the elements that are both in this particular set and in C. So now let's go ahead and look at that. And if you kind of glance at it kind of quickly, you'll be able to see that there's only two elements in there, 9 and 11, that are contained both in the A union B and in the set C. Now I did want to show you this Venn diagram because sometimes visual people, it helps them to see it a little differently. So what I want to do is I want to take all of these numbers and I want to put them in the Venn diagram where they belong. So let's start out with 7. So if you look at 7 in my sets, 7 is both in A and B. So I'm going to put it in this part where A and B intersect. But it's not in C, so it can't go down here. Okay, so it has to stay in that little part. All right, then we're going to look at 8. 8 is the same thing as 7, so it goes in that same little area. 9 is actually common to A and to C, so I need to put it in this section that is common to A and C. And then 10 is only going to be found in set A. 11 will be found in set B and C. 12 will only be in B, and 13 will only be in C. Okay, now I'm going to use a little shading. So let's take a look at our problem again. Now that I have all the numbers in their corresponding places, we can actually shade what A union B would look like. So if we shaded that, we would get those two circles, so the shaded yellow. Now if I intersect that with C, then I'm only looking at the areas that are common to the yellow shaded part and to C. And so you can actually see that this shaded red area, that is going to be my answer. And so that's how we got the 9 and the 11. So it's just a couple of different ways for you to see it. One with merely looking at the numbers in the sets, and then secondly looking at the Venn diagrams. Okay, so let's take a look at another. Okay, so let's take a look at another example, and in this example we're starting out with the same set, and we are actually going to find a different set of operations. Here we're going to look at A complement union B intersect C. So again, you've got your parentheses, and you've got to do that parentheses first. So we need to do B intersect C, and then union it with A complement. All right, so let's do B intersect C. So B intersect C, looking at the sets, is just going to be the number 11. Okay, now A complement is everything that is not in the set A. So when you take everything out, you will get 11, 12, and 13. And then finally, we want to union those two sets together. And when you union those two sets together, you end up getting the set 11, 12, 13. Okay, so let's take a look at how that looks on the Venn diagram. We're going to start with the B intersect C. So B intersect C is going to give you the shaded yellow. So that's how we got the 11. And then A complement is going to be anything outside of A. And so actually anything that is in a shaded area would be in that union, whether it was shaded green or shaded yellow. So it turns out that 11, 12, and 13 were the ones that were left over. Sometimes picture helps us a lot. All right. So one last example. This is same set again, and we're actually going to start with the same set that we started in the first example. So we have A union B intersects C. So very quickly, we have A union B. We intersect it with C, and we got 9 and 11. And here's that shaded area. Okay, but what happens if I actually wanted to find the complement of this whole thing? So that would be any number that is outside of the shaded purple. So taking a look at the Venn diagram really helps us to see that. And so we can actually then form our set 7, 8, 10, 12, and 13. And so that would be our final answer. Okay, so this is going to wrap up this section, and really there's some other examples on there, but I want you to, I don't want to help you with everything. I want you to kind of think about it, but this should get you started on those and using Venn diagrams. All right, hope this helps you out.